So I wanted to start with, did you guys know that actually 76% internationally people use social media, like Facebook apps and all of these others, they are using the internet for that, basically. And guess what? Everybody has a secret. Most of you have a secret too. So this topic is about NodeJs and secrets. So about me, a little bit about me. My name is Tazwar Bhatti. That's my Twitter handle if you want to follow me. That's my blog, and I work for a company called Gemalto. And Gemalto is a security company. You might not have heard of us, but you probably might have used us already, but you just didn't know. That's how secure we are. So if you are a RBC customer, actually, if you flip your card over, you'll see at the corner of it says Gemalto on it too. If you're a President Choice, like they changed it to Simply Accounting or Simply Banking, you actually flip your card around, you'll see actually it says Gemalto. Again, if you're customers of that, you've used us, but you just didn't know. So what are secrets, basically? Secrets allow you to have authentication and authorization, basically. Your username, your password, your database credentials are all secrets. Your API token to actually consume another service is also another secret. Your TLS certificate, you might actually have TLS certificate to mutual authentication between applications. Those are secrets too. So you might say that, okay, I got address and phone numbers, aren't those kind of secret too? They're not really considered secrets. Because if I have your address and I have your phone number, it doesn't mean that I could enter your home, right? So those are more like sensitive information. Those are personal identifiable information. So they call it PII, basically. You want to protect those too, but you might want to encrypt those in some other form. But today we're more talking about secrets of actually allowing to open doors. So in this world right now, what we're living in is basically something called a secret sprawl. We have secrets that are basically in source code sometimes. They're in version control systems. They're in configuration management, version control like GitHub or like Bitbucket or something. Sometimes you see your secret to it, how to actually log into, use an API token sort of thing. They might end up in your configuration management like Chef Puppet or using Ansible to automate your environment. You might actually have secrets inside those code too. So what are the issues of those items basically? When you have code that has secrets, you don't know who has actually used it. Or if somebody breaks in and like gets your secret. And when was the last time actually somebody used this information to actually get it? You have no audit of it. And if you actually have to change this information ever, you have to go through all of your source code to, let's say, change the database connection string. It just doesn't make sense, basically. So what is the desired state to actually have secrets? Basically, you want these secrets to be encrypted at rest and in transit when you transfer the information. And it's only decrypted in memory when you actually need to use it. There should be some kind of an access control to it, and you should be able to rotate or revocation of it. So basically, if I need to change it, I should be able to change it easily and not affect all my applications. So this is actually where the secret management comes into place. A product like Vault. There are other products too, like Azure Key Vault, and there's other like Amazon KMS. Everybody has some kind of a Vault behind it. But this is sort of an open source one that allows you to use Vault easily. It allows you to have centralized secret management. Basically, you remember how the source code and everybody has code everywhere, littered everywhere, the secrets. So it actually take all of that stuff, centralize it in one place. And then you could actually have it encrypted at rest in transit. You could have lease and renewals of your secrets. You could have access controls to your secrets. So who has access? You could say John could only read this information. He could never write to it. You could have some audit trail that Peter actually did try to get this secret. So you know that it was being used. Vault also provides many types of authentication method. You could use GitHub, app roles to LDAP. You could actually plug those all into it. There's also something called dynamic secrets that it provides. Dynamic secrets and encryption as a service. So basically, you don't have to write your code to encrypt the information anymore. You could actually ask Vault, can you actually encrypt this for me and get back the information? So dynamic secrets are more like, you could actually have a lease to a dynamic secret. So let's say I have 42 machines over there that are running, and each one of them could be dynamically generated secrets of it. So that you know that, okay, If 39 was compromised, I know that the trail of like what happened to 39, and I could revoke it and change it. And after 2 hours, it's going to get back a new one too anyways. But at least dynamic secrets allows you to actually, on demand, to generate a unique one per machine. And it's not affecting all the machines that you have. Because if you have centralized one way of information, let's say your database connection, and you have only one, then you're going to get into problems like which one of these 42 machines are being affected. You just want to figure out which one it is. So Vault actually allows you to have dynamic secrets to it. So how does Vault actually store its information? It actually uses AES 256, uses GCM. It allows TLS 1.2 certificates. You are not required to use HSMs, basically hardware security modules. Those are basically machines that allow you to, all they do is encryption, decryption. We're in the business of doing that. And actually, at the end of the day, Amazon is actually using us too in some ways. So how do you actually, well, you need something to encrypt information, right? At the end of the day, Vault needs to have some kind of a keys to actually encrypt this kind of information. So how does Vault actually do it? They actually use something called Shamir secret key sharing. So basically what it does is splits all the keys into multiple keys, and then you could use those keys to actually get a master key. So it's something like this, basically. You have a bunch of keys that are there, and then, like let's say there's 5 keys, and you could pick 3 of these keys and basically create a master key, and that master key is going to be used for encrypting the information in Vault. So it's kind of like, you know how you go to a submarine and then you need to have like a couple of guys that actually put their keys in and turn at the same time, and then finally they could launch the missile or something. So it's kind of like the same idea of it, where you need to have a subset of the keys to actually unseal the Vault so that it actually has a encryption key. And Vault does not actually store the encryption key at all. It's all in memory, basically. It stores it in its memory. So this is sort of like how it looks like when you first initialize Vault. It gives you a bunch of random keys, and then you need to use 3 of these keys at least to unseal it, so that you could actually store these keys at other places too. Or 3 people have these keys with the combination of, then you could actually unseal it. So it says like you have to use 3 keys at least, or you could set it up to how many keys you wanted to. So basically to unseal, you would say Vault, unseal, and then you would provide an address, 1 key, 2nd key, and 3rd key. Once you actually do all that stuff, it would actually unseal, and you could start using Vault to encrypt your information or store your secrets. So how do you write secrets into Vault? You use the command Vault, right? Oh, the other thing is I'm using Vault commands over here. You could use command prompt, and also it provides a RESTful API too. So it's not just command prompt that you actually do this. So you could say, okay, Vault, write me a secret, say hello. The endpoint is hello, and the value of it is world, basically. And then once it writes it, and then you could use the Vault to actually read it too, and say like, okay, tell me I want to read secret/hello. It would tell you, okay, here's the value of it. It's a key value, basically. There's also the advantage of actually writing policies on secrets. Basically, you could say that I want to have a policy on this path. So secret/web, whatever comes afterwards, I want it to be able to read only. Anybody who's authenticating to it are not able to write to it, but they're able to read to it. So you could actually enable a policy based on, you could create a file that actually enables a policy and then assign it to a certain path, as we said over here, secret/web. So how do you read the secrets based on policy? You would authenticate again. You would get some kind of a token to authenticate, and then you would say, okay, let me try to read this path, secret/web/web apps that I have. I want to read it. And if you try to actually read another one, secret/hello, using your token, it would give you a 403, basically. You're not allowed to it because the policy kicked in. So a little bit of demo using Vault. Let me see. So let's try to, I actually have Vault running in my Docker container right now, because that's probably the easiest way to actually get it up and running. So, okay, let's see. So here, I'm actually executing the Vault as a command line. Basically, it's running on port 8200, and I'm saying that, okay, write me the value of hello, like the path is secret/hello, and it will actually say that, okay, the data is written successfully. So if I want to read it, Here it would give me like, what's the value that I've stored in it? Yay, like key value, what's the big deal, right? Anyways, so you could actually make it to read a JSON file too. So let's take a quick look at our JSON file. So let's say I have a JSON file that has like a domain or like a connection to MongoDB, has localhost, ports, and MySQL. Like I'm just making this stuff up. But let's say I have some configuration that I want to store as a JSON file, and I want to actually suck this up into Vault. I could actually do that too. So in here, I'm actually saying that, okay, write me the secret called weather app, and here's the configuration of it. I'm writing a weather application, and the secrets of it, it's all stored into this JSON file. And then I could just say that, okay, Walt, can you read me this JSON file and store it? And I'll actually grab all that JSON, suck it in, and make it into a key value, basically. So how do we read it? Let's see how it looks like. So here, we'll get it. It's a map, contains a local host. I could actually get back these key values afterwards. It's encrypted, stored in a central place. Any of the application needs it, uses a token to authenticate, and actually can get this information. I could also assign a policy to it to say that, okay, it only allows people to read from it. So let's take a quick look at our policy. So our policy is just basically saying that allow people only to read to it. So we could actually tell Vault that here's my policy for it, and basically just, there's a name to our policy, I just named it WEAT, wet, and rather than weather. So this would actually assign that policy to that specific secrets, basically secret path. So maybe I won't go into the wrap token yet. Okay. So as you can see, like basically there's some kind of a token that needs to be talked to it. How do I actually allow people to talk to this endpoint? Vault actually provides something called wrap token, where it's like a temporary token that you could say that, okay, only allow this to be lived for a short period of time. For here, I'm saying that 60 seconds, that it's going to allow me to actually connect to Vault and actually use this. So let me just create, I'm asking Vault, generate me a wrap token. So it gave me a wrap token right here that I could use for reading this information next time. So let me copy this wrap token, actually. Copy the command to actually execute. And then I got to use my wrap token at the end of it. So here, we got back using a wrap token, and we were able to read this information. Let me try it again using that wrap token, because I've used that wrap token already, right? So I get back an error right here, because I've read this information. If somebody stole this information before I actually read it, they'll be able to read it. But if I've used this information already to get the secrets that I want, if a hacker actually steals this information, they won't be able to use this wrap token at all. They'll be like, okay, I'm hitting the endpoint, but I don't get any information. Because I mitigated it by having a short life too, 60 seconds. If I used it after a minute, it would actually give me an error too. So the nice thing is like you can limit the token, how long it's going to be, and all that. So I wanted to go through a weather application that I built. It's just a Node application. So if you look at just simple Express application, basically. So there's nothing really amazing about it. There's only one thing. It's like I'm actually in the process, I'm reading the environment variable to read me an API key. Because at the end of the day, I need this API key. If I look at my routes, I need this API key in my post to actually say that, okay, use this API key and call the open weather map, because I need an API token to actually call this service to actually tell me what the weather is. So if I run this application, I need to pass in for my environment variable the API key that I'm planning to use for my application. So I'm just going to paste. Yeah. Just paste this in. Oops. Should be backslash. Glance weather app. That's what it is. So here I'm passing in a API key right here as an environment variable, which you might be very used to as you're building Node applications. So I'm running against Docker, and I've got the app running. So now let's visit the app. Go host, colon 8080. So here's my weather app, basically. I could type in Ottawa, and it would tell me it's 0.5. So let's see, what's Havana, right? Well, it's better. So now we have the environment variable, but like what's the, like we passed in like the key, how do we secure this information? Is this secure by passing in by, it's not in the source code at least, but is it really secure by passing in an environment variable? So the problem with environment variable is, let's take a look at our, where was it? So 61. Okay, so if I actually Docker inspect, if I inspect my Docker container that's currently running it, I could see all kinds of information in it. And if I scroll up a little bit, oops. Let me scroll up. Do you see this? So technically, a hacker could come in and actually see your API key. If they have access to Docker inspect, anybody who's running Docker will be able to see what kind of secrets you have that you're passing in. Now, a better way to mitigate this, remember how we use the wrap token? Maybe using the wrap token passing in an environment variable would be better, but there's a better way too, actually. Rather than passing in an environment variable, you actually pass in a volume. You mount a volume to it to say it's a temporary file system that actually your application is going to read from that token and then call Vault to get back the secrets. That would be a better way of mitigating this than actually passing in an API key directly through an environment variable. Because what happens is, like, this is one way of getting it, but if you're running on Linux, you could actually read the proc file system and actually get back the same information. Or if there's a system crash or something like that, most of the time, the environment variables are dumped into log file of some sort, and now your log file actually has a secret too. So you don't actually want to do that. The way to mitigate this is actually mount a volume into Docker, and in that volume there should be a token of some sort that your application should be able to read it, and then actually call Vault to get back the secrets. So as I was saying, that if you actually run Docker with like the secrets that you want to mount to a temporary file system, you could actually mitigate this from the environment variable. Store the wrap token into the temporary file system, and then actually has your application read the temporary token, and log into actually Vault to actually get back the information. And have a limited time, basically, maybe like, I don't know, whatever. Docker takes really fast, like within 30 seconds it should be up and running. So you could have a token that's only valid for a minute or two, and actually it should be able to get your secrets when the app starts up. So we talked a little bit about the wrap token, where actually you could wrap the information and then use that wrap token to get back the information. There's also something called app roles inside of Vault. You could actually assign an application a role. So you use the role ID and the secret ID to get back information. So it's kind of like, you know how you use OAuth, like you have a secret, like you create a Twitter application and you log in as a developer and you have a secret and all these information, consumer keys. It's the same kind of idea where you have a role ID and a secret ID. And you could assign a policy to this application. Again, the policy that we assigned previously to actually read this information. And once you log in, then you get back a token. You get back a token, and then you could query for the information that you want. So let's take a look at a Node app that I wrote. So this is a simple application. Are you guys seeing it clear, or should I make it even bigger? OK, so it's a simple application that takes a wrap token from the command line and then basically tries to log into Vault using the wrap token. And I also have the role ID like basically hard-coded in there just for demo purposes. I have the role ID in there, but I don't have the secret basically. So I'm wrapping my secret into a wrap token so that actually I use the temporary time token, get my secret, and then use the role and the secret to actually log in. Once I log in, then I'll get back a client token. And from that client token, actually, I could get my secrets of all the information that I want. So if you follow the code here, basically, I have a role ID. I first unwrap it so that I could get back my secret ID, because I've wrapped my secret. I don't want to pass in these two values into my application, right? I have a one value it's like a username. I've hard-coded the username, but my password is not hard-coded. It's inside of Vault. So I'm trying to actually call Vault with a token that is very short time lived to actually get back my password, secret, and then trying to log in into it. So here I'm actually using the app role to log in, passing in my role ID and my secret ID. And then once I log in, then I get back a token. Now that I've got a token, I could actually use this token to get my secrets, the secrets that I actually need for my application to run. Let's say a database connection that it needs, or some sort of information, or an API token. So once I get back a client token, I could actually call Vault again to say that, OK, can you log me in, and can I actually get the weather app configuration, whatever the information that I want to install. So let's try to get this up and running. So first, I'm going to grab my secret. Oops. So here, I've got a token that I could use. I'm going to copy this. Now I'm going to run my Node app. And I'm going to pass in this wrap token. So once I pass this information in, see, you could see that I'm able to, let's scroll up a little bit. See, this is the token that's going to be used. Here's my secret ID. From the wrap, I actually got back a secret. And using the secret, I'm actually able to get back a client token, which is some other random GUID. And I'm able to query back, remember my DB and all that information? I'm able to actually query back that secret, and I could use that information for whatever I need. I could store it in memory or in my app to actually use it for future sort of thing. So that's one way of actually mitigating. Basically, security is all about mitigating. How much harder you're going to make it for somebody else to get this information. So if you mitigate it, it's not the perfect solution, but you're mitigating the risk of somebody hacking in and trying to figure out your information. So you might be actually running Kubernetes. And Kubernetes has actually a different way of integrating with Vault. So the way that Kubernetes, if you have like a pod, I don't know how many of you are actually running Kubernetes or some kind of a couple of you guys, OK. So if you have an application, like a Node application that is a Docker container, and you want to use Kubernetes as an orchestration to actually run your application, it has a sort of a nice way, but kind of still difficult to get it up, because Kubernetes is not an easy thing to get it up and running, personally saying. So what it does is it has something called a pod. In a pod, you could run multiple applications. So let's say you have a pod that's running your Node application, and when it starts up, it has a service account. So what it uses is a service account JOT. So it uses a JOT and sends to the Vault server to say, hey, here I am, I'm Node.js app, and I have this JOT, basically. Can you give me my secrets? So what Vault does is actually goes to the Kubernetes secrets, say that, here's the JOT, is this a valid JOT or not? And then Kubernetes secrets would say that, OK, yes, it is a valid JOT because it uses the token reviewer API to actually verify that the signature and everything is correct, that this was the pod that was starting up. And then what it does actually, Vault says, okay, the Kubernetes secret says back to Vault, it's good. And Vault actually sends back a token to the application. So now you're not passing in any information. The service actually automatically has a jot initiated for it. You're not giving it any secrets to your application to actually do this. You still have to code some of the stuff to actually say that, okay, read this information and contact Vault with a token to get back my secrets. But at least you're not passing in any wrap tokens or anything else like that to actually get Kubernetes up and running and your application to up and running. So now you still need somebody, an administrator of some sort, to set up these secrets inside of Vault to say that here's the database connection string or some kind of a secret information. But at least it alleviates that your application needs to know the wrap token and wrap it and everything else. It just allows you to use a token to talk to Vault and get back the information. So it's a little bit better. You have to enable Vault to use the Kubernetes authentication. So there's quite a few things in order to do. There's SSL certs that some of my colleagues are having issues with too. You know what I'm talking about. So it's not an easy thing. But like, I mean, there is a way to do this. It involves some work, but this would be alleviating yourself from all these tokens being passed around. It's all in transit, it's encrypted, and it's only in memory that you're using this. So that's pretty much it. We are hiring. If you are actually looking for something, we're looking for JavaScript people. And I'm here all this today and tomorrow too. If you need to chat up with me about security or whatever, feel free. Okay, thank you. Questions? Does the Node Vault library actually provide callbacks and promises? I believe it does, but I didn't wrote the Node Vault. Like I'm saying, I believe it does. I wrote some of the code, but I don't remember quite. It's been a while, so sorry. Other question? Yes. So why would somebody use Kubernetes secrets rather than using Vault? Like why would they use Vault? Why not just use Kubernetes secrets? So Vault provides you with all of the auditing and all of that stuff. So this is sort of, Kubernetes secrets did not used to be secret, like it was still in plain text. So there is no HSM provided for it to encrypt this information. So Vault provides a nice integration with it, basically. That's the reason. Other questions? Are there a pricing tier for Vault? I don't work for Vault, but is there a pricing tier for Vault? I believe they have an enterprise solution too, but all of the stuff that I'm doing is open source. So you could use Vault and not use the enterprise, because the enterprise allows you to actually hook up with the HSM if you want to. So they do have an enterprise level thing that you actually use. They didn't actually say how much it is, so it's one of those contact us and we'll tell you. So, but like for otherwise, all the stuff that we do, even at our work, it's not enterprise. It's all open source. Yeah, we're good. Okay, thank you.